One of the other serious problems related to water here in the United States is the issue of the Colorado River Compact. And the Colorado River Compact was an agreement on how much water should be used from the Colorado River each year. The problem is that the treaty set amounts about how much each place would be able to draw for the river, but they overestimated how much water is added to the river each year. Because of this overestimation, they divvy out more water than the river actually produces on an annual basis. So many years, the river will be completely used up and dried up before it actually gets to the ocean. So the amount of water that they're taking from it is more than the actual river even has. So obviously they're overusing that river and it's creating problems. This map is illustrating the amount of groundwater depletion in million gallons per day. So as these areas get darker, obviously this is one of the lighter areas, as these areas get darker, they're depleting more and more groundwater. So these areas right here especially, they're really overdrawing their amount of groundwater. So they're heavily reliant on groundwater as opposed to other means of acquiring water. One way that this is illustrated is through an aquifer that passes through many of the southern states. This one aquifer is shared between 8 different states. And as a result of that, anyone can draw from it. It's a shared resource. With shared resources, we experience the tragedy of the commons in that no state is really incentivized not to use up the water, even though all of them are dependent upon it. So water distribution is very inequitable across the globe. What that means is that depending on where you are, you won't have as much water if you had lived somewhere else. Roughly 1.4 billion people lack safe water. Safe water refers to water that is free of contaminants. So 1.4 billion people, they're going about their day without having water that they know is clean. 2.9 billion people lack proper wastewater disposal. About 3 billion people don't have anywhere to put their wastewater, so they end up just dumping it wherever as opposed to actually disposing of it properly. So they aren't contributing to water pollution. Population growth can aggravate water problems in that as populations continue to grow, the amount of water that the population demands also increases. So if there's only a set amount of water and that amount of water isn't changing, but your population continues to go up, that means that less water is available per person. So in India, about 8,000 villagers have no local water supplies. China, water table is falling about 2 to 3 meters per year. In Pakistan, lack of water led to riots in 2001. So there was such little water that in order to respond to that, people started rioting just because they had no water to drink. Can you imagine the city of Chicago rioting because they don't have any water? It would be insane. In Mexico, the water table is falling about 3.5 meters a year in Mexico City. So the amount of water that they have available to them is going down by a substantial amount every single year. As it keeps going down, it will become more and more scarce. Among different countries, just like the problem with the aquifer in the south, many different countries can also share the same water source. So this is the Rhine River Basin, and it runs through Europe. It obviously is passing through the Netherlands, Belgium, Germany, France, Switzerland, and just a little bit of Austria and Italy. And what happens is because this waterway is shared, it can cause a lot of problems in that if you input a pollution source into one area, right here on the border of France and Germany, what can happen is those areas around it can be affected and it will have an effect on areas that aren't even located in your country. So what they do in Switzerland has an effect on the Netherlands. What happens to the water here in Italy, it will have an effect in Germany. So it's really in the best interest of all those countries to try to make it so that one, water is available for everyone and that water is clean. But just like any shared resource, they're not always incentivized to provide that clean, available water to other places. The Aral Sea is located in Uzbekistan and Kazakhstan. Both countries were once part of the former Soviet Union. And at one point, it was the world's fourth largest lake. It was about the size of the entirety of Southern California, so it was a really, really huge lake. And in the past 2 decades, the area, well, the volume of the lake has decreased by 75%, meaning that it went down by three-fourths. So this is what it looked like back in 1976, and this is what it looked like in 1997. So the amount of water has gone down a lot. And just like with the Lake Mono in California, what happened is that as the amount of water decreases, the amount of salt stays the same, so the concentration of salt went up. So with that loss of water, the freshwater lake turned into a sea because it became so salty that it was no longer a lake and now it is a sea. So, providing a sustainable water supply, sustainable water use, what it does is it seeks to provide water for future generations without damaging ecosystems. So, the hope is with all things sustainable is that you use something to the extent that it can be replaced. So, sustainable water use refers to water use that doesn't decrease the amount of available clean, fresh water. So, some things that are done in order to increase the amount of water that's available that's clean is the constructions of dams and reservoirs. And some good things related to dams and reservoirs is they ensure a year-round water supply. So this dam, it creates a reservoir up here, and this reservoir, this lake that's created by the dam, it can be harvested year-round. So waterways that would be otherwise maybe only partially available throughout the year, they become fully available because of that blocking of the water supply. And they provide hydropower, so this dam, it's used to create all this electricity on top of making fresh water available year-round. Some cons related to the construction of dams is that it alters the ecosystem. This area right here, it obviously wasn't always as flooded. There wasn't always a reservoir there. Because there wasn't always a reservoir there, we obviously had to alter the ecosystem in order to create that reservoir. That altering of the ecosystem, it's considered unsustainable. We're not leaving it as we found it. So there are negative side effects and increase the likelihood of flooding insofar as if a massive snowmelt occurs and there is a large dam that is blocking the river from flowing, what happens is this area above the dam will all become flooded. That becomes a problem, especially in less developed parts of the world where they have a lot of dam construction, but there isn't really a whole lot of safeguards, and that entire villages have been swept away and flooded due to the construction of dams. Another is sediment deposition. Sediments, they deposit due to the construction of dams. So this series of pictures, what it's trying to do is show the effect of the dam on the Colorado River in the Grand Canyon. And this is what the river looked like before the construction of the dam. So there was the flowing of the river, there were naturally occurring sandbars, there was a thin layer of sand on the river floor, and after the dam was constructed, what happened is those sandbars, they were eroded and sand accumulated on the bottom of the river. They found that what might be the best thing to help the river with its natural flow is perform regulated floods. Keep in mind, rivers naturally, they flood when snow melts at the end of every year. So as this dam, it was regulating the amount of water that was going out, it wasn't being flooded. So what they started doing is regulating floods in which they would have the outflow of the dam be greater so that the river would flood. This would simulate natural floods that would occur uh, regularly on an annual basis. And after they started doing these regulated floods, they noticed that the sandbars had started to partially be restored and the amount of sand at the bottom of the river, it started to go down. So just in terms of being able to provide fresh water, many times fresh water isn't always available, and sometimes all that you have available to you is salt water. And salt water, it can be converted into fresh water through the process of desalinization. There are two methods to remove the salt from a water, and that is distillation and reverse osmosis. This first one is distillation, and what you do in a distillation is you have a container that is full of salt water and some sort of water impermeable membrane above it, so it can be like even as simple as a piece of plastic that water can evaporate through. And what you do is you boil the water. As the water boils, the water particles, they evaporate and are caught by the impermeable membrane, and the salt is left in the container. So it produces steam. That steam is captured and then condensed. The pure water is collected, and the salt remains in the container. In reverse osmosis, what happens is you have salt water. It's on one side of a salt impermeable membrane. So this membrane, what it can do is it allows for the transport of water. Water can pass through it easily, but salt can't. And what they do is push on the salt water using some sort of piston to push the water through the membrane. And the water is allowed to travel through the salt impermeable membrane. So it does, while the salt is contained within that original side of the membrane. It can't pass through it. So you have the fresh water accumulating on this side of the membrane, and the salt remains on this side of the membrane. So it separates the salt from the water and creates fresh water. Another way we can be sustainable with our water use is through reducing the amount of water that we use, and that can be done through reducing the amount of agricultural wastewater. One way to do that is just through a drip and trickle irrigation system. Many times we use irrigation in terms of just dumping large amounts of water onto plants so that they grow. While with the drip and trickle system, you have a tube of irrigation that runs through or close to a plant's roots, and you have water come out of the tube just where the plants are located. So as you can see, there's a wetness on the ground right here and right here. That's where the base of those plants would be. So they're only watering the specific place where the plant roots are, as opposed to just indiscriminately watering an entire area. Another one we can do is just recycle our water. So in this example, clean water that's used within like the sink or the shower or the washer, it's all going down to a gray water storage tank. And then things that don't really necessarily need to be the cleanest water, they'll use that gray water storage tank. So they'll recycle the water and use it for something else. So that would be water that is used in order to go into the toilet. So once you're done using the sink, that same water would end up in the toilet for later use, or you could use it to water the yard or something like that.